One aspect of the climate problem that people sometimes don't appreciate is the timescale. The fact that a large fraction of the carbon we're putting in the atmosphere will still be there thousands, even tens of thousands of years from now. But another part of the timescale of climate change is the timescale of the energy systems on which our society is built. Switching our energy system from a fossil fuel-based one like it is today to a non-fossil energy system would take, at the very least, many, many decades, and probably much more than a century, and tens of trillions of dollars, and that's just for the US alone. The numbers are just staggering. Many of us who have looked at the energy systems of the world and the climate system have a feeling that we may actually not be able to switch our energy system over in time to avoid the worst consequences of climate change. And this is really why solar geoengineering, I think, is an important thing to look at very carefully.
Solar geoengineering refers to a set of technologies that could allow humanity to deliberately increase the planet's reflectivity, reflecting away some sunlight, and so partially offsetting the temperature changes and other climate changes that come from the accumulation of carbon dioxide. This is not a substitute for cutting emissions. If we want a stable climate, in the end, we must bring emissions to zero. But it is a powerful supplement. It could reduce the risks of climate change in ways that we cannot reduce them by simply cutting emissions. It could allow us to reduce temperature extremes that cause real human suffering, deaths from heat waves, losses of crops that will cause real damage in the poorest parts of the world. It reduces the extreme precipitation events. These are the big storms that are some of the most dangerous things about climate change. So the benefits of solar geoengineering in the form of reduced climate risk, reduced crop loss, reduced sea level rise, might amount to something like 1% of global GDP. And surprisingly, solar geoengineering can be very inexpensive. The cost might be something like $10 billion for the whole planet. That sounds like a lot of money each year, but in fact that's something like 1/10,000th of global GDP. So the benefits might be 1,000 times larger than the costs, which is just stunning. And that's why we need a research program.
It turns out there is no government funding at the moment for solar geoengineering, practically none. We have the National Academy of Sciences recommending to proceed with research on solar geoengineering. NGOs, Environmental Defense Fund, where I just spent the better part of a decade, is recommending careful research as well. And none of it is happening.
One of the reasons that people are so hesitant to have solar geoengineering is they think that that will lead us to do less in terms of curbing greenhouse gases. Countries have not been very aggressive in stepping forward in controlling these greenhouse gases. But let's assume that I even thought that this would affect things 1% in terms of the greenhouse gases that were reduced. I would still go ahead with solar geoengineering because I think that we're on a very unpleasant course and we have to do something about it. Solar geoengineering is the most promising technology that we have today.
Solar geoengineering as a public problem brings together many of the ingredients that brought me into the research world in the first place. I'm interested in environmental problems because they're a site of innovation. They're a place where society comes to grips with the fact that we're not human beings alone. We live in a planet that has an environment and we're integrated into it. So here we have one of the most urgent environmental problems confronting humanity, and we're saying that 190 plus countries, we are going to do a set of technologies that will alter the planet in order to make it safer. But we have not devoted attention to the institutional structures that are now needed in order to respond to the challenges. We have to have global buy-in.
One of the main reasons that it's critical to start this research right now is that there are risks that are associated with the introduction of aerosols in the stratosphere. The risks are well known for sulfates aerosols as they exist naturally in the atmosphere and they get into the stratosphere from volcanic eruptions. These aerosols are known to have the potential to deplete ozone and change the temperature of the stratosphere, which has a number of effects. Because of these risks that we know about, we're very interested in exploring new materials and have the potential to greatly decrease these risks compared to sulfate. There's a number of materials that people have thought about, such as diamonds or calcite, titania, but as these are new materials for the stratosphere, we actually don't really know their reactivity. Hence, it is critical that we conduct experiments. We need to find out and try to quantify aspects as soon as possible. Because the worst scenario we want to be in is that in 10, 20 years down the road, we find ourselves in a situation where we say the rate of change from climate change is so big that the cost to humans and the environment is unacceptable, and we are starting to be forced in a situation to do something to try and slow the rate of change. And the last situation we want to be in is to then make an uninformed decision and have wasted 20 years or 10 years or whatever time of potential to try and do research and get to a better understanding and a better quantification of risk, and also have more time to actually try and look for the ideal material to do this.
To me, solar geoengineering is terrifying. We're talking about an engineering project that would affect every living thing on this planet. The possibility that something could go wrong is really scary. And of course, the question of who controls it and to what level do you actually set the thermostat? These are very deep, fundamental questions, and we don't have answers to them. And yet, as scary as that is, as uncertain as some of the impacts of solar geoengineering may be, I think the evidence is clearer and clearer that not doing solar geoengineering and letting climate change proceed may be actually worse as an alternative. And therefore, I think we have to take a very hard look at solar geoengineering and its use in the future.
Solar geoengineering doesn't get us out of the need to cut emissions. In the end, if we want a stable, safe climate, we have to bring global emissions to zero. But the combination of solar geoengineering and emissions cuts can get us climate benefits that you can't get with emissions cuts alone. Whatever your views, our children will face decisions about what to do with climate risk, decisions that will inevitably involve the possibility of doing solar geoengineering. If we have no research program, then what we give them is the gift of ignorance. We need a diverse, systematic effort to figure out how solar geoengineering might work. That effort should be non-commercial, open access, and it must be international. Moreover, this is a problem where a multidisciplinary approach is absolutely vital. We need engineering and science, but unless it's embedded in a larger universe that thinks about governance, thinks about business, thinks about ethics, and even the way this fits in our environmental literature, we won't be able to do something that really helps the world ultimately make decisions about it. We need a research program that thinks about how to reduce the technical risks by figuring out better science and technology, and how to build institutions that have a better chance of governing a technology like this in a divided world.
Trees are one of the biggest carbon dioxide sinks. Trees breathe in carbon dioxide and store the carbon portion, using it to grow. And with sunlight, photosynthesis happens, which means that during sunlight hours, trees emit the oxygen portion that humans and animals need. However, when trees are cut, the carbon stored in them is released back into the atmosphere as carbon dioxide.
Trees and forests are constantly cleaning our air and improving our air quality. They exhale the oxygen we need to breathe, while absorbing carbon dioxide and other air pollution. Here are 4 things that trees do for our atmosphere that are essential for our health and our quality of life. Trees create oxygen. Trees are constantly absorbing carbon dioxide and giving off oxygen as a byproduct of producing the carbohydrates they require to grow. Proper oxygen levels are necessary for humans and all other animals to live. In heavily polluted cities, people are already going to the extremes of purchasing tanks of oxygen to help them breathe. Planting enough trees in and near these cities will help provide the needed oxygen and also help these cities reduce their air pollution. Rainforests have often been called the lungs of the earth because they produce so much of the world's oxygen. The fact is that trees planted anywhere in the world will produce life-giving oxygen, which can travel through the global air currents, ultimately making all trees beneficial to everyone, everywhere. Trees reduce air pollution. Trees absorb and break down most of the major air pollutants, including ground-level ozone, sulfur dioxide, nitrogen dioxide, and carbon monoxide. Just as we easily breathe these gases into our lungs, potentially causing us serious health issues, trees breathe them in as they draw in CO2, removing them from the air. Trees also absorb tiny particles of pollution and smog that land on their leaves and bark. Within the trees, these chemicals go through a series of biochemical reactions, which can convert them to non-harmful compounds. Due to this amazing power of trees, large forests are like giant air purifiers that help clean our air, supporting human health and longevity, as well as all life on Earth. Trees remove humid hazes. Air pollution and water particles suspended in the air create humid haze, which has many negative impacts, including trapping in heat, reducing visibility, and causing respiratory illness. Due to the small size of air pollution particles, they remain dispersed rather than collecting into droplets that would form clouds and fall as rain. Large forests can dramatically reduce these hazes by giving off water vapor along with friendly bacteria that trigger the humid hazes to form into clouds. The pollution and water then rains down into the forests where the trees and soil microorganisms break most of the pollutants down into safer compounds. Trees prevent dust storms. There are many areas in the world where all of the original plant life has been cleared and the exposed soil has turned to dust. Without trees and vegetation to slow down the winds, hold the soil in place, and keep the soil moist, the strong winds pick up the dry dust and carry it hundreds of miles. Dust storms have become huge problems in areas without plant cover, such as Texas, Arizona, the Middle East, and China. These dust storms cover everything in fine dust, causing mechanical failures, lung problems, loss of visibility, and a number of other problems, including spreading disease.